Hello, everyone. My name is Nathan, otherwise known as Old Man Builds, and this is Open Mic Saturday. So today we're supposed to be having Joe in, but Joe had some family obligations, so he'll be in tomorrow. Anyway, I wanted to take this time to talk to you guys a little bit about my Gravity Flyer. So I wanted to show you guys something because we were having a discussion on this in Facebook. I want to show you what I'm looking for here. What you're going to see is on the right hand side, when you're 180 degrees out of phase in order to get something to lift, nothing's going to work. On the left hand side, you're going to see that we're in phase, just slightly off from each other, more of an oscillation. And you're going to see that I'm going to pulse this thing. As I pulse it, you see the little W under it. What that is the actual thing amplifying. So we're amplifying those two waves right there, just like that. We're not going to do anything else to it. That's just what we're looking for. Now, you get readings a lot of times, and you're trying to figure out what they are. So the one on the right, just understand this. When you're out of phase and you hit the amplification, does nothing. Why? Because it's amplifying against itself. So both plates are amplifying into the center and you get nothing. On the left side, you get an amplification. So you're looking to hit the center and then get it to pop up. So I'll show you a little bit of that in how testing goes. Now, this right here is rings. So you get a ring from your Tesla coil anytime you run it. You get a ring from your Gravity Flyer when you run it. And you also get it from your magnets on the bottom when you run it. So with all three rings in phase, this is what we're getting. Now, I just want you to notice they're slightly off from top to bottom. You're going to see them come down and to the right just a little bit each one. That's okay. That's what we want. Just a little bit out. Another thing to look at here is we're in the megahertz range. My Tesla coil, it only oscillates at 340 kilohertz. But I'm getting a megahertz range out of this signal. Now, why am I getting that? Well, partly because I'm changing it with the Gravity Flyer. You have to just understand that my Gravity Flyer is attached to a wire in the center plate. It goes down the throat of my Tesla coil, which means I'm going to adjust all of it. I'm going to change. It's like a beat frequency. I'm going to change the amount going in the magnets. I'm going to change the amount going in the Tesla coil. And I'm going to change the amount based on where the Gravity Flyer center plate is actually resonating at. And it resonates in the megahertz level. That's why we get this. So I just want to show you this as they run. This is in phase testing. This is no piezo being hit at this time, but I just want to show you how it works. So you can start to see the three rings there. They pick up. It's not jumping around so much as it's just showing you where the rings are. One's on top, one's in the middle, one's on the bottom. It's interesting. It looks like it's doing nothing right now, right? That's kind of the thing here. If you see the megahertz, we're still 25 megahertz. We're still getting up there. Now, why would this be important? Because we have to build our Tesla coil to be able to hit that range. So, let me just show you this right here. I will bring it up. And we want this one. Now, this right here is my Tesla coil. Now, when I run this thing, this is actually my previous Tesla coil before I changed it again. But I just want you to watch this. I'm going to clip this thing in, right? And you're going to see right here, I hit the megahertz range. Not near high enough, right? But it's in there. And you say, well, the frequency is really garbage, right? So how do we get from that in order to get our center plate to get up to the real 25 megahertz we need. You see, when the actual wire is going down the throat of this thing and you start to get a signal from the gravity flyer itself, it'll actually change the resonance in your Tesla coil. That's what's so cool about it. So, as we're looking at this, I just want you guys to see it's out of resonance, and I'm just going to move that clip and put it right there in resonance. Perfect resonance. You can start to see it. 370. So it's a little higher than I thought, but 370 kilohertz. So here's the thing. You're trying to get an understanding of why this thing is doing it. It's because I'm overriding the signal in my Tesla coil. The more that I can get it to override, the better it is. So I'm adjusting it. Like I say, it's a beat frequency. So it's going to take the place of everything in it. Because the wires are so thin and gauge, it'll actually go in and change my Tesla coil. It'll change my high voltage. It'll change my magnets on there, and it all changes. That's what's so cool. Now, with that being said, we're trying to draw in scalar waves. So this is one of the hardest things to understand about this. We're pulling in the scalar waves from the outside. We're not pushing them out. We're pulling them in. And what we get when we have that gravity flyer connected to our Tesla coils, we get the bubble around it. So when you create this bubble, just understand this. I'm pulling things in. When I pull things in, things got to exit. What am I trying to get rid of? I want to get rid of anything that's clingy, anything that holds on to it. So you say, okay, what does that mean? Do I want to pull out static electricity? Do I want to pull out gravity waves? What am I looking to get rid of? Well, both. To be very honest with you, what I'm trying to do is anything that clings to that metal, I want to get rid of. So if you see gravity as snow coming down and setting on top of your gravity flyer, I now need to remove that snow. So I'm going to resonate it, and then I'm going to pull stuff in. As I pull it in, I'm going to pull out all of that gravity, all of that stuff that clings onto it, and get rid of it. What it'll actually look like is somebody smoking in the room. That's what it looks like when it happens. You can see it on a red light camera. When you put a red light to it, it shows you where the field is. And then it shows you exactly what you're looking for. So let's go ahead and I'm going to pull that up real quick. If I can find it real quick, and then we'll take a look at what that looks like. Present that. This right here is your field. It looks like it's impossible to see, right? Just take a look again at the center. You can see both plates, top and bottom. You can now see the center. Only the outside ring has any bit of light up on it at all. That plate is ice cold in the center. So you're seeing the heat on the outside of the plates at the top and bottom, which we see in our high voltage testing. What's going to happen here is it's actually going to start going, and we're going to get rid of the garbage. So let's pull this up right here. So you can see it right here when you do the plasma. That's where the heat's coming from, just on the outside. We're not looking for a plasma state. We're looking for the state right before the plasma state. So this shows you the plasma in purple. I don't want that. I want the heat a little bit, but I want the state right before that, the scalar state. I want to bring in the energy. So this is Alexi stuff here, and he shows you the field he's looking for. Now watch. Put it right down the center. See that touch that turns it off? That's the field he's looking for, right there. He wants just a little bit stronger where it doesn't exactly turn everything off with it. But you can see right here, now watch. He's trying to see if there's any movement to pull in the field. And you'll start to see him blur his camera. When he does, you're going to actually be able to see where that field is. So right here, you start to see the field. Right there. He just switched his camera. It's hard to see, but it's right there in front of you. You can see the field right between the top and bottom plate and right in the center. So what I'll do is I'll go ahead and mark it and show it to you. There it is right there. There's your plate. There's your field. It has nothing to do with the rest of the craft. It only has to do with this. So when he starts doing this test, he's showing you where the field is with this red light. So hold on. We see that the Tesla coil right there is connected to the center. It's ice cold. It doesn't show up under the red light. We can see it again right there. It looks like the thing's not even there, doesn't it? Let's see if I can find that one spot. Right here. Do you see those little things, those little particles moving out? You'll see them float up right in front of the camera. This is when things start to exit. It looks like he's smoking, but he's not. He's actually taking all of the charged particles out of the center plate, and it's going throughout the room. That's why he's putting those little things up there so you can see it. So it doesn't actually make a wind. It's just showing you the charged particles exiting. Anyway, what we're talking about is putting the scalar field in there. So we're looking for a mass amount of energy, and then we got to explode it, right? So why am I looking for that instead of looking for charge, or why am I not looking for the actual plasma state? Plasma state uses energy. I don't want that. I do not want a charge state because it's going to put pressure on my disc to go down to the ground. What I'm looking for is I want the energy, but I do not want to use it yet. I want to be able to use it when I push the piezo buzzer. I'm creating this bubble, and I want to push the bubble down. It's that simple. I just want that little bubble in there that he's creating, and like a balloon, I'm going to just set it on a table and push it down, and then it's going to pop up. That's all we're looking for here. I mean, it's as simple as that, but it's as complicated as that too, because you got to understand when you have the bubble, when you don't, that the bubble's thin on the outside, that it's going to be able to let the waves in and out without a solid constructed outside. So normally we think it's something that like, hey, put a bucket over it or something and create an outside, shell. Well, that's not what we want. We want it to go in and out. That's one of the cool things about working with some of this stuff in those fields is that we want to be able to push things in and out. So, yeah, the room sometimes gets saturated right here. So what do I not want? I don't want all that static charge as much as you think. I want the energy from it, but I don't want all the clinginess of it. Not on the gravity flight. In the rest of the room, it's fine. They could expel it all at once and do it all out there. Matter of fact, my electronics absolutely hate it. So let's see. Read that fog has voltages in the sign and time of distortion. So that's something different a little bit. That's more of, how do I want to say this? As you get into the fields and how they build out a little bit, you'll have a time distortion in the center. This thing's, I want to say it's too small, but it's not the right word to say. The field on the plate is too big in order to show it properly like a coil would. So if I showed you this coil right here, all right, and I showed you that inside right here is my vortex, Okay. I don't want to say this. It's going to create heat on the outside of this, and it's going to create right on the inside of this like a static, but you want it to be in scalar. So static will fill up the room, scalar will pull into the center. They'll separate. I guess that's the way I want to say it, though I probably need to work on that definition a lot more. But the room is definitely always saturated with energy, that's for sure. So let me take this thing down right here. Sorry, things over here are distracting me. So basically what we're looking for, guys, is something different here. I want to take this thing and create a pump out of it. So if I took this thing and I tell you the vortex is in the center, I want to pump it. Okay? I want to create the field around it. Just like this. Now I want to take my piezo buzzer right here to the center of it. I just want to pump it. Just like this. As it comes down, it hits there. So what does it do? It's taking the bubble it's forming and it's going like this. That's all I want to do. What happens is it acts like, because you're going to change the viscosity of the air. So the air is going to stay the same, but the way that the bubble builds around it's going to change it. Now it's going to become a little thicker, and it's going to feel like an actual bubble in the air. And then it's going to move. So it's a lot of understanding. And how do I know we're getting there? Well, when this thing pops a little bit off the ground, when it starts to sit up on one leg, you start to understand that you got something special here. You got something that's working for you. Now, I have video of it. It's sitting on one of my other computers, and I'm just waiting a little while to put it out. Once I do, you'll understand we have something building in here. The part that I want to do is just finish it and get it all the way to rise before I completely put it all out there. But I'm trying to give everybody the information now so they can start doing the testing on it, because it's kind of a pain to get to. It's really hard to get all these things lined up and amplified at the same time. So you got to watch when you get explosive versus implosive energy. If you ever see somebody drop a pebble in the pond and they go, well, we're getting transverse and longitudinal waves, well, what'd they forget about? Well, they forgot about the pebble. When it drops into the pond, you're getting a pulse. That's the thing. It goes in there, and as it goes in, everything crashes in back around it, and you're getting implosive energy before you get explosive energy. That's what we're looking to create here. It's just like when you take the balloon and you're pushing down on it on the table, and then it pops up. We want implosion before we get to explosion of it. And we're not even looking for explosive like blowing something up or using the energy. All we're doing is forcing the energy away from the actual vortex. And then as soon as it gets away from the vortex, we want it to rush back in. So when it rushes back in, we get a lift. That's what we're looking for here. So Tron light discs, yeah, maybe. What are we talking about? We're talking about my Gravity Flyer right now. And again, it's open mic. So anybody who wants to come on and talk about some project they're working on, by all means. So free energy. Anytime you create a vortex and you can get it to be stable and it's cold inside, and I mean cold, which means it's got to drop 20 to 30 degrees in the center of it, then yes, you will get extra energy out of it. Absolutely. But you're going to have to create it correctly in order to do that. And the heat on the outside is not real hot. It's like room temperature. It's really not that bad. In the center, right here, has to be cold. Has to be cold. When you get that thing to flow, again, it's not flowing like a magnet. It's not magnetized around it. You're getting a spiral to continuously start. It never stops, and another one starts. And then 100 more start, and then 1,000 more start. And it's starting to create this thing that's bigger and bigger and bigger until it gets really huge. That's why it's continuing to build in the air around you. That's why your room gets saturated, because it's continuously building. So what happens when you have all of that try to make it back down in the center, you get compression. That's one of the main keys to this thing. You really want compression because that's when the energy is able to be used. In my gravity flyer, the flat plate gets compression. Therefore, I'm able to use it. That's why I'm in the megahertz range. That's why it'll continue to go even higher once I amplify it. So I wouldn't be surprised if it goes well beyond the megahertz once I get the right amplification. The hard thing is putting it right on the spot every time, because you have to wait 45 minutes to get this thing up to the right thing and have enough stuff in the field before you can even hit the button. And at that, there's a delay in it. So it takes a minute for it to get there. But yes, free energy, yes. It'll have some free energy in the inside. So that's pretty cool. Let's see. I want to talk to the old man, but he can't do it today. Well, that's okay. We'll pick another day. You can always come on and talk with me. So, guys, I've been working on this for quite a while, and I just got into the coils. I wanted to show you a couple of coils. Let me see. Show you right here. These two right here are what I'm working on next. What we have in there is a coil inside of a coil, and then we have one that's my glow-in-the-dark coil. I'll show you that in a second. Just pull this over here. So Ben's got one of these as well. And it's just a rod and coil frame right here. A rodent coil, however you want to say it. It looks like that. I have the wire for it right here. So what I'm going to use is 25 gauge wire on it. And it's the magnet wire right here. It's 1.5 pounds. That should give me 1493. That's 1440 is what I need for the distance. So 60 feet of it will get this thing filled up. It's 60 feet for each one, 24 lengths. So 1440 total is what's going on there. This other one is a bit different. So it's two halves of the coil. It's a nested center coil. So this right here will get 20 gauge on it. And you can see it's nested. So now what does that mean? It just means it's going to sit right in here inside the frame. So let me bring up the height of this frame. It goes right in right here. So when it sits in there, basically the outside of this thing, again, becomes its own rodent coil right here and is able to create it. And you get a nice big vortex opening in the center. So both of these coils are going to be pretty cool. This one's glow in the dark purple. Let me go ahead and pull that up. I want to show it to you guys. That looks so cool. So give me 1 second. So this right here, let me see it right here. This is what it looks like when it comes out of the sun and sits in your room. It's going to be just basically, it has a purple tint to it. And this is what it looks like when it comes in. So it's completely like glow in the dark. Looks really cool. It's going to look amazing. It's going to have green wire on it. We're going to call it the Joker coil. So as you can see, man, it's just totally awesome. I wanted something totally different than everybody had. Ben has his orange coil. I'm going to have this one right here so we can do a bunch of testing. Now, I should have this thing up and running here probably in a couple days. It's going to take some time to wind the wire and get everything going. You wouldn't think it's that bad, but when you have to put in here, oh God, 60 feet. That's like from my fence to like the middle of my house. Okay, on the side right there, it's a long distance, but then you got to do it 24 times. So it's going to add up quite a bit. And then you got to put it on a stick and put it to the center when you do this. But it's going to be amazing. I got the wire. I got everything. Got the hooks. So we're going to be testing that one here soon. We got the other one. Like I said, 20 gauge in the center, 28 gauge on the outside is what I'm going for. I'm looking to see how close to resonant I can get it. Something tells me that I should probably be using 32 on the outside, but I'm going to go 28 and see what it does. And if I have to make another one, I will. I'm seeing if I can get free in it. I can get free, I promise. So hold on. Might be talking about something else. That's cool. Okay. Oh, it probably meant he's getting free of doing what he's doing. So, okay. Copper's, well, not really. It's coated. So there's not really anything in there. I mean, let me tell you, after the calluses that I have on my hands, trust me, winding wire is nothing. I was winding this this coil here, not even any kind of a burn on it. So yeah, totally not that hard. Not with this stuff. So yes, this is live. So right on, guys. So yeah, that's what we're doing. I mean, we got some coil work to do. We got some things to get into. But, you know, the main thing on these guys is we're looking at it with Ben, and I'm just trying to figure out the magnet size. He says 1 inch is the magnet size right there. So that's what we're going to go with. I'm going to get a 3/4 and probably a 1.26 on there as well. So I want to see exactly what the problem is in rotation. So Ben gets his up and rotating. He's got to put his frequency in there. And when it's a sine wave versus a pulse wave, the whole thing is completely different. So anyway, what I'm trying to figure out on this is when we put a power pack to something, right? It's 19 volts, 3 amps, it'll work. And I could put it on my bifilar coil, no problem, and get the magnet to start flipping. And I can probably get it to rotate in the center. However, when Ben puts it on his, we were looking at the difference in the frequency that goes in. So when you're pulsing, you have to pulse around 30%. You also have to get your volts and amps down on this thing. So you can get it to 19, 20 volts. That's fine. 3 amps. But when it's a cross field, you have to watch it. So you may have to bring the amps down a little bit more. Now, the key to this is the hertz you're in. You cannot be in kilohertz. You have to be in regular hertz. 50 to 60 hertz is where you want to be in this coil to get the magnet rotating in DC only. In a sine wave, and I won't call it AC, I'll just call it a sine wave because it comes from an actual stereo amplifier. So I do not believe it's AC at all. It does have a sine wave in it, which would make it look like AC. However, in no way do I think it's AC. But the frequency itself, that'll have to be in the kilohertz when dealing with the sine wave in order to get the rotation to happen. It's a massively different area when you start working in there. Volts and amps can be lower. So because it's working differently, it'll have the rotation caused differently when you get there. So we actually have to change them both when we do each one, and you're going to have to figure out that. Now, Ben was using a, sorry, let me remove this. Ben was over here using a frequency generator. I kept getting told that it doesn't go to 0. I looked it up. It should go down to 0, and you should be able to pull the hertz out of it. So that way we can go back to the right way of doing things. So what I'm going to do is I'm just going to take my signal generator and put it in the right way. Okay, I'll put a sine wave in there. Again, not AC, just a sine wave. And I'll be able to rotate this thing with very little volts and amps in it. And I'll go ahead and put that on a trigger circuit. That way I can protect it, protect my frequency generator from the rest of it. So you got to have a trigger circuit in there, got to be able to use it the right way. And all it is it's a pass through for the high side. And then on the low side is your signal generator. And all that does is add the signal to the voltage. So that's it. That's all that it's doing. And it's telling it what to do. So that's what you got to understand about those. So, all right. Thanks, Nathan. You made me just realize a key point in my work. By the way, V-Series is going to be on tomorrow not tomorrow, on Monday on the Fringe Think Tank. And he's got some cool things. I'll go ahead and bring that up in a little bit. We're looking at fractals and how they get into coils and stuff like that. How much current will a guitar string take? I don't know. I've never built a pickup in my life, to be honest with you. AC is only switched DC like 110 volts, 1900. Not really. How do I say this? You could try to tell me all day that DC is like AC, but when you start to shave off the tops of the DC to make it like AC, it's not. It's just not. They behave differently in coils. When you hit something with a straight DC signal, your magnet's going to just jump once and be done. When you hit it with the sine wave, it's going to continue to go. If you have your pulse right, then you can get this thing to run. If you have kilohertz in there, it will not run on DC. Not that way. So let's see how much Chris. I have no idea. I don't play with guitar. It's not like that. Just FYI, instead of posting the link, join the link to your main channel. I did post the link to the main channel. I can do it again. And there you go. I posted it in the beginning when I start. No link to join. Well, I will send you one right now. Give me 1 second. I'm getting it for him. And there you go. I just sent it to you. I am sorry for that. I just figured someone would tell me they want to jump in, and I'd send it. So here we go. So yeah, if you want to jump in, go out on ahead, man. As long as you don't talk about coils and medical. YouTube has just been crazy on nailing me on that, and they won't let me talk about it, even though I know they do a lot of things, and I'd love to talk about it. It's just they don't want me to, so I can't. Got me in a lot of trouble. So anyway, let's see. Yeah, on the ACI, the coil affects the resistors. Trying to, yeah. Yeah, we all know the rules of YouTube. All right. I'm going to pull this up because let's see if I can't show you this real quick. And I'll just show you on my bifilar coil what we're looking at for. Let me see right here. If I can find it real quick, it'll just take me a minute. Scrolling down forever in this thing. I wanted to put a bifilar coil on my gravity flyer at one time, and oh god, it weighed a ton. It wasn't going to work. So let me see if I could just find that real quick, and I'll show it to you. No, it's still further back. But the cool thing is what it does to the magnet, and I'll show you the difference in it. And of course, I can't find it right now. So, just a second. Should be there in a minute. If not, I'll have to pull it out of my other files. Okay, I'm going to have to pull it out of my file then. Give me just a second, guys. And I'll have that up for you. Oh, come on. It's here somewhere. Testing, and more testing, and it got sitting on this file. Oh. All right. Well, apparently it's not there. Anyway, I guess I can't show it today. I don't know where it went. That's crazy. Anyway, I'll just tell you what it did. It basically, when you put it on your finger, it'll basically, let me find something small over here. I don't have a magnet here with me. Basically, as you run your DC through your coil and it's sitting over here, your magnet starts to go like this. And it only does it when you have the pulse DC at about 50 to 60 hertz. If you don't do that, it won't do it. If you start putting in the kilohertz, it won't work at all. And then it'll start to look like the signal itself is actually just one solid signal. It'll look like it's always on because it's pulsing way too fast for it to understand what's going on. So it'll look like a solid on. So you'll see your magnet pop once, and then that's it. It won't do anything more. So let's see what we got in here. They love to censor. Yes, they do. They got me good with it. Yeah, you can't say that. Right on. So anyway, that was kind of what's going on with this, and we couldn't get the thing to run. Now, I don't have it in front of me, so that's why I wanted to do my own coil and build it myself, because then I can put the stuff in there the way I think it does, the way it works on my bifilar coil, the way that we can get this thing to rotate so we are all consistently on the same page. Now, I am building other coils as well. So this, like I said, I keep showing this one. This is my first attempt at Gerald's coil, and it's off. The windings are wrong on the outside for sure. 100% is because I didn't run it in a bifilar way. Then all the actual ways that it's wound though are almost dead on. I got a couple that this outside one's wrong. This one inside is right. That one's right. And I could tell you by the direct distance that it is and exactly what we're doing there. Now it needs to be thickened up. There's only like one layer on each, and that's not close to what we need to be. It needs to be several layers. But the cool thing is it gave me something to test with and start to see where if there's any resonance in it and not. There's not a lot of resonance in it, guys. There's a lot of wire missing in it. So it cannot resonate. It does not have the feel on the outside to resonate and get the heat that's out there. Therefore, I cannot get the thing to cool down in the center. So it doesn't operate properly because I built it improperly. Even though it looks nice, it's basically just a reef for my door at Christmas time. That's about what I got. So let's see. Water fuel cars. Yeah, I didn't get nailed on the water fuel cars at this point, to be honest with you. So we're okay there. Let's see. Yeah. Let me just say it this way. I got a warning on YouTube, and I do not want to strike. So I'm not even going to play the game of walking the line. You know what I mean? I just have no interest. So, let's see. HHO is not allowed. Yeah. Well, if you start talking about it's going to replace gas, they get on you. I haven't gotten that one yet, but I don't doubt it. So, Yeah, it's funny. Absolutely funny. So yeah, that's kind of what we got going on there. So we're looking at building these coils, and what I absolutely find fascinating, and just let me share this with you. When I'm building my gravity flyer, and then I see other people building coils and stuff like that, I mean, you guys do know it's the same process. We're not changing the world here. It's all coming back to a couple things. Okay, we're pulling in scalar waves. We're pushing out any kind of charged particle. So when I say charged particle, basically I just mean we're not looking for a charged state. We want to eliminate the charge by keeping the energy inside. We're not looking to go to a plasma state. That's too far. And I don't even think the space is filled with plasma like they tell you. I think it's a state that's before plasma. And where do I think that scalar fits in? Well, it's not completely charged, but it is energy in there, and it's not plasma. So it's got to fit right in there in the middle. That's the way I see it. Other people may be seeing it a little differently, but that's exactly where I see it. And this whole thing right here, they're all the same. You know what I mean? But they're all going to work the same too. All we're doing is building up the energy in it, and then it's like a little diaphragm. All we're doing is tapping it. That's it. We're tapping it. We're creating a field around it, and we're tapping it. We're pushing out all that energy and letting it suck back in quickly. That's all I'm doing in my gravity flyer. It really comes down to something real simple. You know, it's not what you guys think it is. It's creating one state of energy in there without using it. I'm not using it for charge, and I'm not using it for plasma. I'm creating energy in the center in order to just build the energy up. That's kind of the misnomer of things. You think when nothing's going on, then you did it wrong. Well, you just don't know the state you're in. And if you don't do high voltage experiments, it's really hard to find it because you don't understand where it is. You don't understand the difference. When I sit there and I put something on a coil, I can tell you when it's in a charge state because it'll move. Then it'll stop moving for a second. Then it'll go into a plasma state. Okay? It completely changes when you start to do that. You start to understand, hey, where's the movement? Why is it moving? What did it take to get there? So it was just so much different to find it. And then once you do find it, it'll amplify the energy in it. That's the cool thing. It actually amplifies the energy once you find it. That's the only time you do. Otherwise, it just uses the energy. Plasma is a uses of energy. That's why light is a usage of energy. And light's invisible if there's no usage of energy. If it doesn't come in contact with some form of amp, you won't see the light. And then depending on how many amps you put in there, it changes the light color. That all shows up in high voltage testing. So you'll be able to tell you exactly where you're at. Oh, let's see what people say. You said something in your last live. You said it all. Yeah. Well, sometimes the old man's smart, you know. I do so many experiments on things, man, and I keep changing things in order to see him move, in order to see him do something. And that's kind of what you have to do here. So it was let's see, I don't talk about the thunderstorm generator because I don't want to get in trouble. And it's not that I can't verbalize it. It's just, man, everybody plays it, get in trouble for music because it's there's a copyright on the music thing of it on one of them, and then another one, it's all proprietary. So I stay away from it. That's how I'm using my O-scope. I finally finding all the resonance points. Yeah, that's right. You should start to find them. And Gerald had his O-scope, and man, let me just tell you, if he just tuned in the scope a little bit and isolated each H wave, because he's got them kind of built out like this, just isolate them so you can see each one. God, it'd be a whole different world, man. And I just don't know if his scope would do that, but that's kind of what he has to have because he's getting H waves. Then he gets the backward H wave, which is his back EMF, and he's getting the same actual H wave in it. And it's no different than a Bedini. So you only get that kind of thing when you're amplifying something backwards. So he's getting back EMF, he's getting regular energy in there to amplify. That coil's special, man. It's probably one of a kind. I don't think anybody will ever rebuild that thing. So oh, I don't know what that meant. Something just died. Hopefully he didn't kill his coil. He just ordered a new O-scope. Oh, I see my RX cut for that. Huh. Oh. Oh. So, yeah, I could probably break it down probably a little bit further. But what I'm trying to get at, guys, is we're all doing the same thing, and I think we're all just taking a different approach at it. And I'm laughing because I keep seeing everybody doing the same stuff. Like I'm looking at these things, and we're looking at weight on a scale, right? And it's not lift. And by the way, creating pressure on a scale is not lift. In no way will it lift. It's not the same thing. So you could create a massive charge on something and get it to push down on that scale in the pounds. It still doesn't lift. It's just not. And I've done it. It's not lift. Because what you got to understand with TT Brown is he not only used the actual plates. See, this is what people don't understand. They're creating pressure in one direction. But he's also got right in the center post, he's got like a Tesla coil sitting right in there. He's creating the field on the outside, but he's creating the plates on the inside. And he's looking for a scalar field to be able to build inside of it. That's what he did. And when you look at Otis T. Carr, he's doing almost the same thing. I mean, these people aren't out of line with each other. It's how we see it's out of line. That's what's going on here. We're not seeing that they're all crossing over each other and told us the answer 500 million times, and we just can't see it correctly. That's what it is. I mean, I don't know how many times I've seen the same thing over and over and over again. Then people do experiments, and no matter how you want to say it, if I see your experiment, I know what you're doing. It's not really that hard. Once you really start to see where everybody's going with this stuff and how it's been used in the past, how you replicate it, and then the experiments that you're doing, you're going to start to see the same thing over and over again until it dawns on you that they're all doing the same thing. Now, is there different levels of it? Yes. Are they used for different purposes? Absolutely, yes. But you can't create one without creating all of them. And that's why you do the testing, because it's going to go ahead and personify everything that you're looking at. And that's why I do the high voltage, because it tells you where the fields want to go, where they want to rotate, where the vortex is, how it's put in the center every time, why your plate is always way colder in the center than it is on the outsides of it. How come this thing will drop 20 to 30 degrees in the center of it, and you're looking at it going, well, why is the outside room temperature and the inside 30 degrees lower? Well, it's because you vortexed it, and you got to build up in there. Now, your Tesla coil produces cold energy. People don't understand this. Build a Tesla coil that's wider, and you'll start to find it out real quick. Okay? Just something this wide. And then build it out of a bucket. I dare you. And then you'll find that center of it getting cold, man. And you'll start to understand the vortex idea. The Tesla coil is already creating part of it. That's why when you create a coil, you're actually building part of a Tesla coil in it because of the way it resonates. So hopefully everybody starts seeing that, man, and start to understand it so that we can really get all the same stuff on the same page. Yep, it's all the same thing. It's different ways of getting there. Oh, 99% is fake. You have to do it yourself. Well, I'll be honest with you, there's a lot of people out there who are saying they're getting something, but can't prove they're getting something. And I don't know how to tell you to distinguish the difference. I can tell you by the parts that they put into it. what they're getting, what the circuits they need, which circuits they don't need, which things that they're barely hitting because they just found it all of a sudden, versus did they create the circuit to get it? One of the ways is that, do you know what voltage you're doing? Do you know what heat does to your circuit? Can you take your coil and light a lighter in the center of it and change your amps? So, do you know how to do it? I mean, really honestly, do you know what to look for? And if you do, this stuff becomes easy. Yeah, I could do that. Yeah, I can change it. I can add heat to my system right away. Then I could change the amps. Why? Because heat changes amps, and it also reduces your frequency. So when you get the anomaly in your system and you're looking at it going, why is my voltage all over the place? And you go, well, it just does that once in a while. Well, no, because you don't understand it. Because you really don't get how voltage is working for you. You have to be able to understand it on its level. We think of voltage in AC and DC. It's a shame. We should think of it as earth energy, because the earth's energy creates something different than what we're getting in AC and DC. AC and DC are just there to mimic it. They're not what we're looking for. We're looking for that earth energy, that crystal energy. That's where we got to start going with this. That's where you got to start to understand it. It's completely different in a certain way. You can start to create it with voltage if you know what you're doing, but a lot of people won't even come close to sniffing it, because they can't get it in their head that the actual energy from the sun would change. Like, for instance, my gravity flyer, when I put it outside, it'll change the distance between my plates that I have to put into it. Why? Because the sun itself is adding more amps. And as soon as I add more amps to any bit of voltage, it takes me out of the scalar state and it puts me into the plasma state. Or if it's really cold, it can really take me from my scalar state and put me down to a complete charged state when it's really cold outside, because of a temperature difference. So you have to adjust your plates accordingly. All high voltage is distance between two plates. That's really it. And how you evaluate that distance and find out what you get. So you're going to have to really understand it. So when I see somebody talk about their experiment, what they put into it, if they did not tell me that they changed the frequency, or do not have a setup that shows me that they're changing the frequency, or that they understand why they did it, then I'll know if they have it. So just different ways of getting there, man. So when I say Tesla coil in a bucket, what I'm just saying to you is build it bigger than normal. Okay. Yeah, we do 4 inches is basically about what one of my Tesla coils is. Like this gold one over here and my red one, they're 4-inch diameters. Okay. So they show up things differently than my other one that's on my gravity flyer over here, which is 2 inches around, okay, in diameter. So when I say put it in a bucket, build it bigger than what you think it is and see if you can't see the difference in the center. It'll always be colder in the Tesla coil. As soon as you start running it, the outside will produce heat goes out, and then you're going to get coldness coming in. Why? Because it's going like this, the energy. How do I know that? Put your circuit underneath the Tesla coil. Nothing will happen to it. Why? Well, it's because it's not necessarily directly getting in the way of that. Just like that. Not getting in the way of it. The only reason the top is energized is because you put a little post at the top and connect it to your number 2 coil. Therefore, you're completing the top. Right there, you're completing it. You're not allowing it to flow without it. A lot of people run top loads on their Tesla coil, and they never take off the top load to find out what exactly they're doing. So sometimes you have to break an experiment down. I have all kinds of different Tesla coil circuits that I use. I use my ZVS, and then I also use my Slayer exciter. I use a modified Slayer exciter, and I also use a way, way more modified ZVS, like completely modified, where I can put the heat in it, I can put the cold in it, I can change the frequency of it, I can do everything to it. And I have my gold one, which is 370. So if I wanted to take that thing down, kilohertz down to hertz, I just have to put enough mass on my gravity flyer or something attached to it in order to get the frequency down to that level to be able to resonate a tuning fork. So to kind of throw that in your head and see if you can figure out how I pulled that one off. So anyway, there's just a lot of things going on. It's a suitable energy, not voltage, not charge, not static. It's all of those things all interacting within each other. Yeah. But you have to create each one in a specific way to get them to interact right. That's the key, isn't it, Gerald? You're not just going to pull that one out and not get all the proper things in there. That's kind of one of the key problems too. People think, hey, I could just, shortcut it. I'm just going to go over here and I'm going to build up a bunch of static and I'm going to put it in there. Yeah, that doesn't work. That doesn't work. It's not going to work. It won't ever work. You cannot take a static generating machine and put it in the center of your flying machine and get it to work properly because you didn't create it properly. So it's a hard lesson to learn, but it's a true one. And trust me, I got shocked a lot of times trying. Yeah, sometimes bigger is better. Sometimes you just have to see it to learn it. Guys, that's why I do high voltage on this, because it doesn't lie to me as much as low voltage does. Just be making a string a little thicker down. So here's the key to that. You want that wire to have the crappiest insulation ever. You just don't want it to have good insulation. People go, well, I put a high voltage line down there. Well, yeah, good for you, but you're not getting what I'm getting. You want it to be able to change things. That's why you do it. You're looking for the anomaly. You're not looking for the most consistency. You're looking for the anomaly here. You're looking to create something different. That's why the cheapest wire I could get, I go down to the store and I buy trailer wire. Why? Because it's real thin insulation on it. And it's only meant for 12 volts. Well, now I'm going to throw a Tesla coil frequency into it. Why? Because I want to be able to take it from it. So I'm robbing the thing of energy, but my Tesla coil still oscillates just fine. It doesn't blow up circuits, doesn't do anything like that. Not when it's just during normal operation. Now, when you go to add heat to it and you start using the one down the throat and you're using the wire itself that comes off the number 2 and you put them in conjunction with each other, trying to create an explosive energy, yeah, then you'll start blowing circuits. Yeah, trust me, I probably blew 20 boards in a row doing it. And that's a real hard one to figure out how to do. But yeah, there's a lot of explosion going on there. You start frying everything. They're just not built for that. So I want to show you something that V Sears showed me. And I want you guys to take a look at it. So give me 1 second and let me see if I can't share my screen. I'll put it up. And make sure everybody can see that. Okay. Basically, everybody knows what this is, the fractal pattern. Now, the sound may be horrifying to hear, but I just want to show it anyway. Let's zoom in a little bit. You notice anything about these shapes? Probably every pattern you've seen in a coil is sitting right in here. Oh, it's horrifying to hear. Maybe I should mute it. Let's see if I can find the right one. Oh, look at that. It just tells you there's a triangle. Go up here. It's almost there. Almost getting there to the right shape. I could probably play with this thing all day, man. This thing is so cool. So hopefully the noise isn't too bad for you guys. I'm going to do a little bit more. But what it's showing you is the exact patterns that are in this thing, right? So you're going to be able to see what it is. Now, I don't know 100% if the sound is correct for each one. Like you would be able to take the frequency of that and put it into your coil, you know what I mean, and get the thing to, if you have that pattern in there, to work right. So I would hope that it's close, but I don't know that it is. So I can't verify that. D will dampen the sound. Okay, I'll hit D. Very coil like, yep, it is. Hit the 4 and the 8. You mean just the number? Let me try it. Hold on. Oh, I didn't even know it had this. Okay, hold on. Anybody see that in a coil before? I've seen that one right there. I've seen that one too. And that one. You notice the depths that they're going at. Now, I want to show you guys something. So, let me pull it up real quick, and I can go back to that and show you that again, but I wanted to show this to you. Oh, where did I have it at? So this right here is a Christian mandala. Okay. Now, when working it backwards to find out where the wire placement goes, here's the deal. If you're building the outside of this, never cross the next one over. And then you'll be able to get it. You have to find the pattern in it after that. But let's see how it breaks down. We probably saw that one in that generator. I didn't see that one. I saw that one. I saw that one. Let's see. Let's go back the other way. You could start to see the patterns and how they break down. Right here will give you a look at it. Do you notice the rings yet? Each one of the patterns breaks down into the ring. And then you get this. Now, when you look carefully at it, do you see all the different layers of rings in it? That's kind of what it's showing you. Some of these things are natural fractal patterns. So how would I say that they do this? When you're looking at the fractal patterns built on that machine, you're also looking at fractal patterns that they put into mandalas. It's also part of nature. This whole thing is tied together. They're not just telling you, hey, this looks cool. They're giving you this whole book to open, and it's up to you to research on how to build it. This didn't take long. This is maybe 6 hours worth of work to figure out every single pattern that's in there. And you're able to see them layer by layer by layer. All out of that one mandala, but it ties right into the fractal pattern that it comes in. Now you start to see it. If you can see it like I do, you'll start to see these mandalas completely differently. We're creating something different here. We're not just looking for one thing. We're looking for why they did it. What is it going to produce once we redo it? What were they trying to tell us? It probably has to do when you look at the mythology around each one of the patterns. Like, for instance, there was a Christian mandala. I'm sure the Christians have a certain way of looking at it, could tell you what it is about and stuff like that. And then we'll find out if it's actually doing that. Does it say it's a pathway somewhere? Do they say it's meant for healing? Did they say it's meant for something else? I don't know. But it'd be neat to find out, because then we can see it and verify if it actually is. That's kind of why I did it. So we need to double the slit experiment and the lasers spinning, maybe. Just gave me a great idea for a paper. You're writing a bunch of papers out there. I tend not to do that, even if I come up with something. I may be a dumb question. I wonder if it would happen if you ran a scalar input through the coil. Well, the coil itself, in most cases, already has a scalar input in it. It's just certain things aren't amplified like you think they would be. Hey, guys, what's up? So that was kind of cool when you get to this stuff right here. And V Series says to pull up 4 and 8. So give me just a second. Let me pull up that thing again. And I'll take this one down. All right. So now we got this one here. So let's see what it does. I'm going to wait till Monday, and I'm going to let V Sears describe this. But there's something special going on here, and I'm not holding it in the right place. But you see that field right there? It's right there when it goes out to all the rest of them. And I'll let him describe that on Monday when he comes on. I just find it interesting that all these things are in here. Yeah, there's that pattern again. There's the next one. There's another one. It likes to tell you that they're in there. All of these can be recreated in a coil. Anyway, that was the number 8 on there. These things are free, guys, on the download on here. And they're really cool. So I can't look at the comments while I'm messing with the thing. So let me see what this is. Plane of inertia right there. Whirlpools draining into each other. And magnetism story. This thing is really cool, guys. And I'll let the Master V Series do it on Monday. But I wanted to show you this because we're looking at different patterns and why they're created a certain way. Well, yeah, there's good reason for it. So I just thought it was very interesting when we start to get into these coils and stuff, why we're creating them and why are we always doing a vortex at the center? I mean, it should tell you a lot when we're doing this stuff right here and why we're doing it. Now, Gerald and I have been working on some circuits and stuff, and he showed some on Wednesday, and I bought some parts, and they should be coming out. I don't know if I'll have them all in by this Wednesday to rebuild some of his stuff, but when he does the thing for the speakers and stuff like that coming out of your amp, that's one of the circuits that I wanted to do to protect my amp so that I can run it on this coil. So that's one of the reasons I got it, so that we can start doing all this stuff right here and get it situated. That way we're all on the same page. So, guys, if you want to build this coil right here, I can leave the Thingiverse. I'll drop it in the comments when I'm done. And that way you guys can go on and print it out if that's what you guys want to do. Again, I'm using 25 gauge wire on it. Ben used 24 on his. I just didn't have it on hand. And the footage on this is 1,493. And it's going to be for this coil right here. The footage needed for this coil is 1,440. That's going to give you 60-foot lengths. Because I have 1,493, I'm going to go a little bit more so I can have a little bit more leeway in case it's a problem. So I'm going to probably put it at maybe 60 and a quarter, something like that, on the feet, and it'll be good. So 60 and 4 inches. I think it was, 4 inches. Give it just a little extra just in case I need something, because when you twist it, it could change the overall distance of it based on the twist, because you're going to have to wind it from post to post and then keep it with tension on it, and then pull out the thing on one side, and it's these little hooks. Let me open this. They're just connected to these little eye hooks. I bought these ones because of that little gap right there. I want to be able to slide the wire in and out. So hopefully you can see that. And then it'll hook here. You put this in your drill and spin it while the wire's on there, and it'll spin it around for you, keep it tight knit. And then you're good to go to put it on a piece of PVC. And Ben shows all that, where you take the PVC and wrap it around it. You cut the edges so that it basically has a shape like this on the top and bottom that the wire goes through and loops. And then that way you can shove it through. And thankfully, this coil right here has a big enough hole in it where you're not going to have a problem with that. So there's Ben right here. You can get one of the spring coil open like I got as well. Thank you for that, Ben. Yeah, Ben's pretty good about this stuff, Ben. He's got it all figured out on exactly how it goes. So I'm excited to see once I get it done what I can actually we could do at the same level, if that makes any sense. Like same circuits, same magnet. What can we recreate together? That's kind of what I'm looking at. So I think that'd be pretty cool, man, when you get this thing going. So that's probably why I'm building that one. I'm building the one Gerald's building just because it's fun. So I'll let the master do his job, and then I'll just have a little fun with it and see what it does, and see what kind of things I could do with it with the circuit. And then I'm sure once I get into it, it'll be game over, because I'm going to start playing around with this thing all day until I can figure out everything and just get out a notebook and start writing it down and put it on video. And same thing I do with my gravity flyer. One thing people don't know probably about me is when I get to my oscilloscope, man, I sit there and I zoom things in. I look at it and I look at every single pattern that's going on and everything, and I break down every pattern because I want to know why it's doing it and where it's doing it, where the amplification is, where everything is. And once I find that, then you can really start to work on these things. And it's kind of a key feature. It's the reason you buy one. So might as well do it right. If Nathan can create some of my experiments, remind me, well, it gets your proof of concept for over Unity. I mean, you got it. I got it. It's there. There's no hiding it at that point. So Yeah, Ben's excited, man. Yeah, this should be fun, man. This is meant to be fun. This is why I do this stuff, guys. I mean, look, I'm retired. I get to be sitting home eating potato chips and watching the game. But instead, I'm here with everyone else, and I just want to learn, man. I just want to build these things, and everybody brings a new angle to this. Every person out there has a different way of looking at it, and it's testing theories. I mean, the funnest thing to do is to get a bunch of people in your garage together, and everybody throws out a theory, and then we get the circuit together and we build it, and we find out. That's the coolest part about doing this stuff, man. I love that. You know what I mean? When you get so many things out there, okay, let's see what works, what doesn't work, why is it working, why is it not working? Sometimes in failure, you get the greatest success because it told you exactly where to go with it. Sometimes, in my case, it starts on fire or it starts smoking. I had both. And yeah, it's just fun when you start doing this stuff, man. So stay tuned for the next workshop. Yeah, Pimp My Coil. Yeah, I try to do things a little different than everybody. That way, people don't think I'm doing the same thing, man. That Joe called it the Joker coil because it's purple and it's going to have green winding. And I'm probably so appropriate. But you have to see it in person, it looks more purple. Kind of, you saw it in that one photograph, man, it looks purple. But no, it's kind of cool, man. Oh, let's see. The coils are art. Everybody has a unique one. Yeah. So, anyway, guys, that's pretty cool. So, another thing I was working on, people probably don't know this, and I'll just tell you, I'm trying to take my piezo buzzer to my Tesla coil, one of my other ones, and I'm just trying to be able to hit the signal on it, and I want to see if I can get that sucker to spark higher. So, one of the testings I'll be showing on my channel is that experiment where I took the piezo buzzer, I hooked it to the ultrasound machine, I put it to my Tesla coil, and then I pushed the button. I'm trying to get it to jump higher. I'm going to see if I can't explode the energy out the end of it. So there's a way to do it. You put it on the top, you go like a pump and see if it does it. And that probably blow my circuits, but that'll be fun. And then we'll put it on the bottom and see if we can't blow it out the top. So I think that's going to be one of the coolest experiments that I do here in the next week. It's going to cost me, though. Everything costs me. I always break something when I do stuff like this. But, oh, man, what do we got going on here? Research and development experiments are smoke and mirrors. Yeah, I don't know that they're not fake. That's for sure. I don't fake them. I have no desire to do anything like that. None. Just none. There's no reason to, man. I got better things to do. I'd rather create voltage all day than screw with somebody. That's just not my thing. Oh, you know what? It does get expensive. One day I was out here and I had my gravity flyer on my table. This was one of the last experiments I did in my garage. So the static electricity is all over my table, right? If you ever wanted to see everything on your table, just go at once. I did it. It literally was so thick in here that in the immediate area of 6 feet, anything in that radius was dead after that. Absolutely dead. I was sitting there trying to hit the multiplier on this thing with my piezo buzzer, right? And I go, okay, let me just put it up here on the table so I can get a good look at the height of it and I can see it with my own eyes. So as this thing was building, I'm going, man, this is getting kind of weird in here. My, hairs are sticking up. I go, oh man, the air is kind of thick. You know what I mean? And then I go over there and go, well, let me have a big brain fart idea and push the button. Yeah, I paid for that one. Everything within a 6 foot radius was dead. Every bit of it went in the trash. Power supplies, ZVSs, anything with a MOSFET in it, completely blown. That's the power that's put in these things. You don't realize it until you do it. Heck, I had it connected to my table sitting right here. It's metal on the on the bottom portion of it. You can see here, it's all metal. Yeah, don't ever use that as ground. I paid for that one too. That one almost took out my computer. I had to stop it in seconds, man, because it was starting to fry stuff. So we started seeing things smoking when that was going on. I lost a couple printer boards and stuff like that because of that one. So never try that as ground. Make sure you have a real ground to it. So the adventures of the old man doing stuff. Oh man. Yeah, I haven't blown up a battery yet. Hold on. Is that real smoke? Yeah, it was real smoke, all right. Let's see. I've ever seen the movie Batteries Not Included. Remind me of that. Yeah. Yeah, it's expensive. Local EMF, yeah, it basically was. Like I didn't have any extra hard drives out at that point. I keep those in the house, man. A lot of the stuff I had to put in the house. Heck, I got a TV behind me that doesn't work because of this experiment, man. I can't even turn the thing on. It's complete dud. I had to replace the one I'm looking at right here in front of me on my regular screen. I've replaced that one as well. So, yeah, I tend to mess with things on my desk or next to my desk, and then they start to light up. Yeah, I paid for it. I got smart and just did them outside. That's why I got that. You see the little cart here with my gravity flyer? I just go outside with it now and make all the adjustments in here, roll it outside, set it up, do it. You're going to have to learn to start, caging your electronics around it when you actually get it far enough away. And then wire distance, how to calculate for that, because the ZVS likes to stay right next to it. So you're just going to have to figure things out when you get into that kind of testing. And it's not always easy. Oh. Let's see. So neodymium. Neodymium generally a weak type of magnet. Once you get it past its center point, yeah, it is. A lot of people don't realize that. Neodymium is junk after it gets past the first couple inches. And the field drops off massively. Like I had it at I think it was 2 inches away, and it was at 3.2 or 3.4 volts. And when I was rotating at 7,000 RPM, then I moved it 2 inches more, and it was 0.9 or 0.8, and it was completely different. The whole number was different. It was a complete piece of junk. So, yeah, I know those are big magnets, man. They're pretty tough when they're close, but when they get far away, the field sucks. I like regular magnets. That's what I like. Alnico magnets? Yeah. Aluminum? Oh, so you're excited switching resonance. Picks random things. I actually have one. I probably should show it. I was getting let me turn this off. I was getting a pure DC field out of one of my Tesla coils. I should probably show you that. I don't know where it is right now. Hold on. It might be here somewhere. Oh, I love looking around in this thing. I got so many pictures in here. Oh, I should have just pulled it earlier. Give me 1 second, guys. I'll find it. Oh. Let's see. Wanted to show this real quick. By the way, I'll just show you this real fast. This is my that's my bifilar coil that I used to do the magnet testing. That thing is massive, and it's going to work great for that Rodin coil. Once we get it set up, I'll be able to use it as a pickup coil. So, way better. All right, let me get back to what I was looking for here. Oh, let's see. And it's not there either. Oh. Nope, still not there. Okay, well, I guess I can't. Man, I'm just not having any luck of finding any of these videos today. Sorry, guys, it'll take me just a minute to find it. Oh, here we go. Here we go. So this is my big coil, and I set it up on DC only. And this is just on the ZVS. We're running relatively low power. I don't have enough power in this thing to do anything. But the Tesla coil worked great. You can see it lights up right away. There's no breakout on the top. Now they're getting a little bit of breakout, but the distance without a problem goes way out. And this is just on the same ZVS circuit that I usually use on some of these things. And when you put the DC in there, you're not looking for the sparks out of the top. I'd put, AC in there. But it runs pretty good with that little circuit on there. And you can see we're only 20-something volts in this thing. It took my cellular exciter, got, 40 volts to get out that far? So this is, you can't see my oscilloscope, but it's completely in resonance right here. So, and I got my cellular exciter to get in good resonance, man. I got the breakout to be good in that one too. So, yeah, you can get these things to work out. One thing it does do is you'll see it right in there when you're in resonance. It scales real easy as you turn up the voltage. You see the oscilloscope in the back. It scales up and down real easy. Has no problem whatsoever amplifying. None whatsoever. So it's just kind of neat to see that. And then you can probably see the breakout just a little bit. There's not much more breakout than this coil gets. That's about it. And I have not run it for sparks yet. I only run it on DC because I was looking for a certain field. That's what I was looking for with this. And it's 28 gauge wire, 4-inch PVC pipe. And I believe I'm at 19 inches on the height of it. So it's quite a bit of winding that went on in this one. So you gotta love testing these things, man, once you build them. Well, I should put this one in the front yard and start messing with it. Start messing with people coming by. Maybe throw the sparks out of it. So, oh, don't need that one. Yeah, but it's kind of a cool trip, man, when we're doing some of this stuff in here. Let me remove some of this stuff out of here. Yeah, anyway, I guess we don't have a whole lot of people out there that want to come on. So, not much going on here today, guys. That's all I really wanted to talk about. So, anyway, I guess that's it. So, I mean, if you guys want to come in and talk about this stuff, leave me a message. I will put my email here in the description so you guys can find me. There you go. Just leave me a line if you always want to talk and come on the show next time. It's all good, Gerald. We all got stuff we got to do, man. I just usually I'd have Joe with me today, but he had some family things and he had to take care of, and he said he'd be in tomorrow. So we'll just talk with him then, man. He's got a lot of cool stuff he wants to share, by the way, on what he's doing. So anyway, thank you guys very much. It's a short stream today. That's about it. Have a great day, and thank you for joining me.